This is lesson 4, the last lesson about functions, and this is all about transformations. What are transformations? Transformations are everything that you will do to an original function that is going to change its shape and position. All right, so let's see all the variations that you are going to have, and you have a total of 6. Okay, let's start with the first 2, and these 2 are going to change the function, the position of the function, up and down and left and right, not changing the shape itself. For this example, I just use the simplest parabola, which is x squared. Okay, this is the original sketch of the parabola, and I want to change it vertically. Okay, so what do? I just have to add to the function a number. If I want to move it up by 2 units, I add +2. If I want to bring it down by 3 units, I subtract 3. And that's all you have to do. Okay? So the difference that you have between x squared and x squared plus 5 is the fact that the parabola moved up by 5 units, every single value. Okay, so the shape stays the same and it just goes up. What happens if you want to change now the parabola as a whole without changing its shape, left and right? Now you'll have to add a value or subtract a value, which I call t, on a function. This was to a function, and now I call this on a function. All right, so let's see as an example, starting with the x squared as well. Let's say that I want to move it to the left 4 units. Then what I have to do, if it is to the left, I have to add 4. If I want to move it to the right, I have to subtract 4. This is a little bit counterintuitive, so pay attention. To the left, I add. To the right, I subtract. And the number or the value that you want to move to the left or to the right is the number that you have to add there. As simple as that. So we can talk about, if the shape of the function doesn't change, okay, we can talk about a translation through the vector minus ts. All right. You don't know this yet. Vectors is now a topic that is covered in Pure Math 3. All right, but you know from ICSE or whatever qualification you had before the A levels, that vectors can be expressed as columns like this, in which the top number is the x coordinate of the vector and the bottom coordinate is the y coordinate of the vector. Okay, so what does this mean? This means that whatever number you have there is the value by which the function has shifted horizontally. Okay, so again, if it is a negative number, it went to the right. If it is a positive number, it went to the left. And s is the value by which it moved either up and down. So again, in my example, I said that you wanted to change it to the left. It was 4 units, right? So you have to do x squared plus 4. Okay? So what is going to be the corresponding vector? Is going to be minus 4, 0. In this case, I'm just shifting it horizontally. Nothing happens vertically. So it would be minus 4, 0. Okay? The coordinate of the vector that comes after this transformation is a negative of that number over there, and the value of that number as is. Okay? Let's now see situations in which you have the reflection of the function. Again, the shape itself will not change, in the sense that it's not going to be stretched or deformed, so to speak. It's just going to be reflected. And you can either reflect it on the x-axis or on the y-axis. Okay? If you multiply the function by -1, you reflect it on the x-axis. So for example, if you have this function now, x minus 2 squared, okay? If you multiply the whole thing by -1, all right? So minus x minus 2 squared, what is going to happen? This is going to be flipped like this, okay? What if you want to flip it on the y-axis? Then you have to multiply -1 on a function. Do you understand what the on means over here? Means inside of a function, so to speak, okay? So what do you have to do? You will have to, where am I? Here. You will have to put the minus inside of the structure of the function. So in this case, it will be minus x minus 2, okay? The minus is going to be there, minusing just the x, not the whole thing, all right? It's just the x that is being minused. And this is going to do what? It's going to reflect it on the y-axis, okay? So the vertex, which in this case was 0, 2, becomes 0 minus 2, okay? Then the last two are about actually changing the shape of the function. Let's say that you want to stretch it vertically, make it bigger, but the x coordinates of the point stay the same. It's just vertically that you are stretching or compressing. By stretching, I mean either the function becoming bigger in the y-axis or smaller. It's just a matter of thinking of the scale factor. A scale factor bigger than 1 makes it bigger. A scale factor smaller than 1 makes it smaller, okay? And in this case, I talked about the sine function. We didn't cover this yet. It's going to be the 5th or the 6th chapter, the one before last. But anyway, all you need to know is that it is something like this, has this shape, okay? And if you multiply this by a value a, then the function is going to be stretched vertically by a scale factor corresponding to a. So let's say that a is 2, okay? So instead of having f of x equals sine of x, you'll have g of x, cannot be f of x, it's going to be another function, so g of x equals 2 sine of x, making this bigger vertically with a scale factor 2, basically 2 times as big. So if this over here was 1, now will become 2. If this was -1, will become -2, okay? But the x coordinates of all these points is going to stay in place, all right? So as f, scale factor is whatever that a is. If this was 1/3, then it's going to be not stretched, but more compressed to a height that is 1/3 of that. So this will be 1/3 minus 1/3, all right? What if you want to now do the same, but horizontally? So vertically, it stays the same, but now horizontally is going to either stretch or compress. Now it's going to be counterintuitive, like a little while ago, all right? If you want to stretch it, or better yet, if you multiply a value b on a function, okay? So here, if instead of sine of x, you have now sine of bx, this is going to cause a stretching of the function, but with a scale factor, not b, but 1 over b. Okay, this is very important. So let's say that you have now, instead of sine of x, you have sine of 2x. This means that the function is going to be not stretched with a scale factor of 2, but compressed with a scale factor of 1 over 2. Vertically speaking, the y coordinates are going to be the same, all right? So in this case of the sine function between -1 and 1, but the x coordinates are going to be compressed with a scale factor of 2, okay? So this is what you're going to have. If you want to make the function more stretched, then you have to multiply. Let's say that you want to make it 3 times as stretched. So you have to multiply by 1 over 3. Because 1 over 1 over 3 is 3, the value that you wanted in the first place. Make sense? Okay, so let's see a particular case that involves the completed square form again. If you have a function, a parabola written in its completed square form, something like this, then you know that the vertex is going to be minus pq. You know this for a long time, right? And this will correspond to a translation of the parabola ax squared that starts with vertex in 0, 0, right? The vertex of any parabola that is just ax squared is 0, 0. It's going to be a translation of this parabola through this factor. Look at what happens. You are adding p to the function and adding q. You are adding p on the function and adding q to the function. So minus pq is going to be the translation vector that you will have, right? Meaning that this original function, the ax squared, is now going to be moved, shift over here with the translation vector minus p q. All right? Let's say that you want to do now a combination of various transformations. This happens most of the time, but it's not. It's just a rule of thumb. It's not one of those mathematical established rules. The order by which you would have to follow is this over here. So, well, let's just go through the numbers. 2, 6, 5, 4, 3, 1. I don't urge you to memorize this, because if you look at what you have to do, your mathematical knowledge, so to speak, is going to be enough for you to decide which transformation you want to make first or before the next, so that you end up with the thing that the question is asking. So I wouldn't worry too much about memorizing this, because I'm pretty sure that you will be able to figure out which one to do first.